So hello guys, welcome to this video, and in this video we will be solving our question last index. Okay, so first let me explain the question to you. The question is pretty simple. It says that you will be given an array, something like this, and you will be given some data. Suppose the data is 3. Okay, and you need to give the last index of occurrence of this very data, right? Suppose we were given the data 3, then 3 appears here, here, and here, right? So the last occurrence of 3 is 6. So we need to print 6. Okay. Now, two more things. If the data doesn't exist, then we need to return or print -1. Okay. And the second thing is we need to do this recursively. So I hope you understand the question. Now let us move to the solution approach of this problem. Okay. So like every recursive question we solve here, we are also using our higher order thinking, and we are setting some expectation and faith, right? So let us see what will be my expectation for this function so that I can solve this problem, right? So I will have a recursive function. First of all, let me call it last index li. Okay, I will pass this array, index, and data to this function, right? We need to search this data, that is why I'm passing this data, and at what index I am working, that will be told by this idx. Okay, so initially I am saying that this index will be 0. Initially this index will be 0. Why? Because I am starting from here, right? I need to start from here and check my array, what is the last index of this data. Now in my example I was taking that we are searching for 3, so let us call that, say that the data is 3. Okay, so now I am at index 0 and I am searching for 3. So what is my expectation from this function? When I called this recursive function, what I expected from this recursive function is that it will start from 0 because I gave the index as 0. It will check every element in this array on its right and will search for the last occurrence of 3. So the last occurrence of 3 in this array was 6. So it will return me 6. So my expectation is from this function is that whatever index I have passed it, it will check on its right and return to me the last occurrence of whatever data I am searching, right? So now this is my expectation. How can I meet my expectation using my faith? The big question is, what should be my faith so that I can meet my expectation, right? So let us see something like, if I am at 0, okay, if I am at 0 and I ask my neighbor that you go from your index and check on your right and give me the last occurrence of 3. Okay, so I asked one to check on its right and give me the last occurrence of 3. So it returned me 6. Okay, so 6 is the last index on which 3 is appearing on the right of 1. Okay, so now my faith was I will ask my neighbors to give me the last occurrence of the element I am searching for. And now what is my work? Now my faith is done. My faith was it will give me the last occurrence of the element. Now my last occurrence is given to me. Now my work is I will check whether whatever this faith has returned to me, this 6 is equals to is -1 or not. See why? Because if this element does not exist, suppose I was searching for 11. Okay, so I am at 0. I asked my neighbor 1 to check for 11 on its subarray. Does 11 exist? No, 11 does not exist. So this will return me -1. Now my work is to check if I am 11. If I am 11, then I will return myself. Why? Because my faith was not able to find any 11 on the right side. That means I will return myself, right? Okay, now the second scenario. Suppose again I was trying to find 3. So when I was searching for 3, I am at 0. I asked my neighbors, give me the last occurrence of 3. They will return me 6. Now, do I need to check myself? Do I need to check myself? No. Why? Because if 3 occurs on my right, then that occurrence is the last occurrence of 3, not me. Even if I am 3, even if this was 3, it was not the last occurrence, right? The last occurrence is 6. So if my faith is returning something to me, that means I need not to check myself, because I already have my answer on my right. Okay. So I will explain the faith to you once more and how we get our expectation from our faith. So the gist of the faith is simple. I will ask my neighbor. I was at 0, so my neighbor is 1, to search for 3. Okay. And if it returns me -1, that means it was not able to find 3. Then I will check if I am 3. If I am 3. If it was able to find it, that means it gave me anything other than -1. Then I need not to check myself, just return whatever my faith has returned me. Okay. So I hope the faith and expectation is clear. If not, then I will show you a little bit what happens here and at 6 and 7, and you will understand everything. Okay. So see, when I am at 7, what was my faith? What is my expectation from 7? First of all, my expectation from last index array 7,3 is that it will give me the last occurrence of 3 from 7. From 7. So is there any other element on the right? No. Is 7 3? Is the 7th index 3? No, it is 9. So that means this will return me -1. So this will return -1 here. Now I reach at 6. So what is the case for 6? 6 got -1 from 7. 6 got -1 from 7. That means 6 will check itself. 6 will check itself. Why? If it would, if this 9 was not 9, 3, right? Then what would have happened is that it would have returned 7. So the last occurrence would have been 7. So I wouldn't need to check myself. But right now it is returning me -1. It is returning me -1. That means the 6th index will check itself. Is it 3? Yes, it is 3. So this 6 will return. This 6th index will return itself, not -1. Right? So now let us try to write a code for this. Okay. So I have already taken the input. This is my array and this is the data I'm trying to search. So the first thing is, I will call my recursive function, provided the array, the initial index is 0 because we need to start from 0, and the data that I am searching for. Okay. So I sent everything to it. So what is my expectation from this function is that it will give me the last occurrence of this data. So I stored the last occurrence in this. It will return to me the last occurrence. So I stored the last occurrence and then I can simply print it. Okay. So this is done, right? So I printed the last occurrence. Now let us move to our recursive function. Okay. Let us move to a recursive function. So what did I say? For doing my own work, I will have a faith on my neighbor, right? I will ask my neighbor, what will be my neighbor? Index. My index +1 will be my neighbor, right? I will ask him to give me the last occurrence of the given data. Okay. This is my faith that it can do it, right? So it will return to me the last index. Now I will store that last index in my recursive answer, right? So my recursive answer have the last index. Now, what was the condition when I needed to work? I needed to work if the return, that is the recursive answer right now, is equals to -1. Because in this case, what I told you guys was that my faith was not able to find the data on my right. So in this case, I need to do something, right? I need to do something. So if the recursive answer is equals to -1, then I need to do something. What do I need to do? I need to check myself. If I am equal to data. If I am equal to the data we are searching, if yes, then return myself, return my index, and if not, then simply return -1. Why? Because my faith was not able to find the element, and also not the element. That means we were not able to find that element. Simply return -1. If this is not the case, then what we do is we simply return whatever was returned to us by our faith. Okay, so return recursive answer. Now, what is the base case? The base case is if index becomes equal to dot length return -1, right? Return -1. Why? Because suppose this was our array 2 3 5 7 3 1. Now I have reached here. I check for whatever was my faith, and then I jump at array length. Okay, 0 1 2 3 4 5 6. So this is my base case, that now my index is at the array length. So is there any element here? No. Why? Because the array is 0 based. Okay, the array is 0 based, so element will be only till 5. So now at my array, now I am at my array length. So this is my base case. So can I ever find my element here? Obviously not, because it is equals to the array length. There is no index there, right? So it will return to me -1. Now let me try to run this code. Okay, let me put it down here. See, accepted. Let me try to submit it for all the test cases. Then we will do a simple dry run. After the dry run, everything will be pretty much clear to you guys. So it is taking a little bit of time submitting. Kindly wait. Okay, yes, it's done. So correct answer. Let me do a little dry run for you guys so you can understand it better, right? So this is my recursive function. Let me take it to my whiteboard. Let me put it here, erase everything else, right? Okay, so see, what will happen is I called this function for 0. Okay, and let me say the address of this array is 4k. Okay, let me say the address of this array is 4k. So when I do a recursive call, what will happen is I will get a stack. Please don't mind my writing, I'm new to this. Okay, so yes, a stack will be created, right? So the first function call was array. So the address of array is 4k. Then the initial index was 0, and the data we are searching for is 3. Okay, so basically we are here. Okay, what this 0 will do? This 0 will put a faith on this one, that this one will give me the last index of P on its right subarray. Okay, so it will call 1, right? It will call 1. See, for 0, function was called, then base case was not hit because the index is not equal to array.length. So I called my neighbor. I did a recursive call on my neighbor. So I called 1. Again for 1. We enter here, base case is not hit. Again we do a recursive call for our neighbor. Okay, so this will happen till I reach my base case. Okay, so 4k, third index, searching for 3. Again 4k, fourth index, searching for 3. Again 4k, fifth index, searching for 3. Again 4k, sixth index, searching for 3. 4k, seventh index, searching for 3. Now I reach my base case, 4k, eighth index, searching for 3. Now is there any index 8? No. So for 8, what will happen for 8? The function will be called for index 8. We will reach here if index is equals to array.length. Yes, true. It will return -1. It will return -1. So from here 9 will get -1. 9 will get -1. Now what is the work of 9? 9 will check what is the value returned to me. It is -1. That is the element does not exist on my right side. That means I need to check myself if I am the element or not. So is 9 3? No, 9 is not 3. See, the value returned is -1. So now 9 will check, am I the value? No, 9 is also not 3. So we will return minus 1. Okay, so 9 will again return minus 1 to 3. Now 3 will check. 3 will check the 3 will check what is the value of return. The return value is minus 1. So 3 will again check if I am that element. Yes, I am that element. So 3 will return its index, right? Look here again. What will happen is 9 will return minus 1 to 3. 9 will return minus 1 to 3. 9 will return. Okay, so minus 1 will be returned to 9. 9 will also return minus 1. Now 9 returns minus 1 to 3. So 3 checks if the return is minus 1. Yes, the return is minus 1. That means there is no element. This element does not exist on my right. So it may be a possibility that I am that element, right? So it checks if I am the element. Yes, it is the element. So it returns its index. Now it returns 6. Now for every value on the right, they will never check. They will never check. Why? Because we are never returning minus 1. We have once gotten 6. So the answer of my question will be 6, right? So hope you guys like this video. If you guys like this video, please subscribe to Pepcoding. Thank you.